Circuit. Okay, so we're talking about natural numbers, right? You were taught these before, I think. I don't actually assume anyone knows anything at this point because I don't remember when people had COVID like this time and then COVID like out times. I just assume no one knows anything. But at some point in time, I believe you were taught this. Okay? Natural numbers are the natural numbers you count when you are a toddler. Okay? There are no genius toddlers who start at 0. Okay? There's no 0, 1, 2, 3. What do toddlers start at? 1. And then they don't go like 1.25, 1.5, 1.7. There might be some genius toddlers. We're looking at the average Joe Blow toddler here, okay? 1, then they go to
2.
Yeah, and then they go to
3.
3, and then that's a low toddler. We don't go 1, 3, 5. Okay, so we have like just your average Joe Schmo toddler is 1, 2, 3. Naturally, that's what they count, correct? That's the natural numbers. So we go 1, 2, 3, etc. Yeah? That's the natural numbers. That's all they are. The natural numbers are the natural numbers you count. 1, 2, 3, blah, blah, blah. Right? Whole numbers. Anyone hazard a guess? Yes. Whole numbers. Yeah?
Ones without a decimal place.
So close. So close.
0.
Yes, so you were right. We just have to take the negatives off of yours. Okay, so whole numbers are the next numbers in life. Okay? We have the naturals, we have the toddlers. They're like 1, 2, 3, 4, 5. They're just geniuses. They can even sometimes 10, 9, 8, rocket counting, you know? And then we get to our next part of life and we're like, there's a 0, which means it's nothing. And so life, whew, great. So whole numbers are the natural numbers plus the number with a whole, which is the 0. Okay? So whole numbers are natural numbers plus 0. That's it. That's all. The only thing that's different about a whole number and a natural number is the number 0. Then we get into junior high and our life is ruined. We learn about integers. Integers are exactly what you said. They're all the numbers without decimals. So that's negatives and positives, right? That's all the integers are. So we get into this world where we're like 1, 2, 3, and then we're like, hey, there's a 0, and then we're like, hey, there's negatives. Okay? That's integers. So we can go dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay? Then we have these crazy things called rational numbers. Rational numbers are the not crazy numbers because they're rational. So rational numbers can turn into fractions. Rational numbers are numbers that can turn into fractions. So actually, natural numbers are rationals. Now some may say, well, how the heck is a natural number a fraction? What can every number be put over? 1, correct? So can all the natural numbers be put over 1? Yeah, and then can they be a fraction? Mm-hmm. So the natural numbers are rationals. Because, for example, 3 is 3 over 1, correct? Do we agree with that statement? So it's a fraction. It can be made a fraction. What about whole numbers? Can 0 be put over 1? Yep. Whole numbers are literally 0 plus the naturals. So if 0 can be put over 1, whole numbers are rationals as well. What about integers? Can negative numbers be put over 1? Yep. So integers are also rationals. And just plain old fractions. Another example. So examples of rationals could also be like 3/4. It's an actual fraction. What is 3/4 as a decimal? Anyone know? 0.75. Do you know how to put 3/4 into your calculator? What is this? What is this? It's a division sign. So if you just go 3 divided by 4, right? It's just a division sign. Every fraction is a number divided by another number. That's all a fraction is. So it's 0.75. So actually, terminating decimals are rationals. Terminating decimals means decimals that stop. Any decimal that stops can be put into a fraction. Okay? So terminating decimals. They're rationals as well, because you can put them into a fraction. What other decimal can become a fraction? Anyone remember? Starts with an R. Rhymes with repeating. Repeating. Yes, you are good at this. All right, repeating decimals. So like 0.3333, dot, 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 dot. That is actually a third, correct? It can turn into a fraction. So decimals that stop, decimals that repeat, can be turned into fractions. All right? Now, irrational numbers are decimals that can't do either of those. So decimals that don't stop and decimals that don't repeat are irrational. They just go on and on and on, just like an irrational person, but just go on and on and on, so do decimals. So, one of the most known irrational numbers in the world is pi. 3.14159, dot, 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 dot. Keeps going on for life, right? It doesn't stop. Pi is irrational. It doesn't terminate, it doesn't repeat. There are people who spend their entire lives trying to prove that pi repeats or terminates. It's their life's goal. They research it. I'm glad I'm doing this and not that. But one time at one of my years of teaching, I've been teaching, this is my 17th year. But in one of my years, I had an article out that they figured out that pi terminated. And by the next day, it was disproved. I was like, oh, for a few seconds there, you thought you really had something there, sir. And then just disproved. So I would think I would just stop trying to prove it. But. So any decimal that doesn't terminate or doesn't repeat. So I could just make something up. 12 decimal 1379468 2 9er 1 5 7 blah, 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 blah. I just can't let it repeat. I can't let it stop. Right? That's it. It's irrational. Does that make sense? So sometimes we have letters that are determined as irrational numbers like pi, because it holds all the decimals, right? Some people say pi is 3.14. It's absolutely not 3.14. You're actually rounding it before you actually put it into the question, which means your question's bad. When are you allowed to round? Anyone know? When are you allowed to round? Sky? At the very end of the question. I had Skylar last year, so she's going to give me the right answer. Very, 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 very end. At the very end. At the last answer. That's when you're allowed to round. So if you round anywhere before you do your answer, you're wrong. Why is that? Because there's a thing called numeric response. And say the answer to the numeric response is 2.7, and you give them 2.6 because you rounded earlier. What are you going to get for a mark? Nothing, which really sucks because you actually knew what you were doing. You just rounded earlier. You broke yourself in a rounding rule, right? That's the absolute worst. When you know what you're doing, you get it wrong because you rounded early. Like, that's the saddest day in Mrs. Lepp's life. I'm just sad. Yeah. So when are you allowed to round? The answer. That's it. You hold all your decimals. And the greatest thing about these fancy, expensive calculators is they'll hold all the decimals for you. And I'll show you all the different ways you can do that. Because you can store decimals. You don't have to write them all down. You don't have to type them in. If you are typing them in, you are wasting your time. Okay? Which time you're not getting back. So we'll make sure we know how to do that. Now, the real number system is everything above. The real number system considers all the rationals, the irrationals, the integers, the whole numbers, the reals. Okay? So the reals are the naturals, the wholes, the integers, the irrationals, and the rationals. Now some might say, what's an example of not a real? That's everything I know. You've just stated every number in my repertoire, some might say. True. The non-real numbers are something like the square root of negative 16. Are you allowed to take a square root of a negative? No. Those are called imaginary. We don't really talk about them because they're imaginary. But then you go to university and they're like, there's these things called imaginary numbers. And I'm like, if it's imaginary, why do we care about it? Like, we're not allowed to have imaginary friends. Why are we allowed to have imaginary numbers? But we are. Not in your world, though. So don't worry about it. But the only reason why I bring up imaginary is because, so you understand that there really are numbers in the world that aren't all real, but everything we use is real. Okay? Prime numbers. We're going to star this baby because people get this wrong on tests all the time. Prime numbers. Star, star, star. Highlight. Smiley face. Underline. Whatever you need to do to bring your eyes back to this. If you're writing out your notes, why? So you have something to look at when you have no clue how to do something. Correct? That's why we write out notes. These are your notes. So if I tell you to star and you choose not to, you don't have to do it. It's your notes. But I usually tell you to do something for a reason, right? So it's easy to come back to. Anyone know what prime numbers are? Yeah. Numbers that don't have any, you're very close. I know what you're trying to say. You're trying to say numbers that don't have more factors, like lots of factors. Like 12 has lots of factors. It's like, what's a factor? Factor is a number that multiplies by, two numbers that multiply give you that number. So like 1 and 12, 2 and 6, 3 and 4. 12 has lots of factors, right? So it's not prime. 18, 1 and 18, 2 and 9, lots of factors. It's not prime. That's what you're saying. You're just completely correct. Prime numbers are numbers that only have two factors. Okay? Numbers with two factors. But it has to have two factors that are different. I'm going to put in brackets. So it's usually 1 and itself. Those are the two factors. 1 and itself. And most people can get on board with that. So like 5. What multiplies to give me 5? 1 and 5. That's it. So is 5 prime? Yeah, two factors, 1 and 5. Does that make sense? I want you to put on your paper another number you think is prime. So you don't have to tell me it. Put a number on your paper that you think is prime. Has to be 1 and itself. That's it. So like 8's not prime because it's 1 and 8, 2 and 4, right? 6 isn't prime. 1 and 6, 2 and 3. Do you agree? So you write on your paper, you don't tell anyone else, you just put down a number you think is prime. And we'll see if it turns up in our prime options. This is the trickiest one. Is 1 prime? By my definition, let's look at my definition. Definition says number with two factors that are different, 1 and itself. Two factors that are different, 1 and itself. Is 1 prime? No, what multiplies to give us 1? 1 and 1, how many factors is that are different? 1. So many people, if I can get you to leave today knowing that 1 is not a prime number, we're in a good position. People will tell me 1's a prime number all the time. You might have wrote down 1. It's totally fine, I don't care. We're not testing you today on what's a prime number. It's a learning curve, right? So 1 is not prime because it actually has only one factor. So what's the very first prime factor? 2. And what can we say about 2? It's actually the only what? Prime factor. What do you think? Even. 2 is the only even prime factor because it's 2 is 1 and 2, but once I hit 4, I have 1 and 4 and then 2 times 2, right? So I actually have 3 factors, 1, 2, and 4. So once I hit 4, I have 3 factors. When I have 6, I have 1 and 6, 2 and 3. I have 4 factors. So 2 is the only even prime factor. Is 3 prime? Yeah, because what multiplies give me 3? 1 and 3, and that's it. What about 4? It's even, so it's out. It's only even as 2. What about 5? We said yes. 1 and 5. 6, it's even, it's out. 7, 1 and 7. 8, nope, it's even. 9, 1 and 9, 3 and 3. Is 9 prime? No, because 9 has 1 and 9, but also 3 and 3. The moment I say 1 and 9 and blah, 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 once I go past 1 and 9 and then I add some more numbers, it's not prime. 1 and 9, 3 and 3, not prime. 10's even. 1 and 10, 2 and 5. 11, is it prime? Is there more factors than 1 and 11? No. 11 has 1 times 11 gets me 11. And as long as there's not more, 11's prime. We agree? 12, 1 and 12, 2 and 6, 3 and 4. There's a whole bunch of factors. That one's out. What about 13? 1 and 13. That's it. That makes 13. So it's prime. 14, 1 and 14, 2 and 7. Out. What about 15? 1 and 15, 3 and 5. It's out. So it's not prime. What about 16? 1, 16, 2, 8, 4, 4. Right? Out. 17. Is it prime or not? 17. Prime, because all I can do is 1 times 17, and I get 17. That's it. So if I go 1 times the number, and that's the only thing that multiplies to give it, it's prime. 18? No. 1 and 18, 2 and 9. 19 is prime. 1 times 19. And then there'll be more. 23 is the next one. 29. Nope. Yep, that's good. Okay. What about a composite number? It has to have more than 2 factors. And this is the hard buy-in. People want to put 1 somewhere. 1 doesn't fit either of these. 1 isn't prime. It has too little. And it's not composite. It has too little. So 1 is actually not prime nor composite. Okay? So composite numbers. What's the first composite number? 4. Because 2 is prime, 3 is prime, 4. 5 is prime. What's my next composite? 6. Not 7, 8. Because 8 is 1, 2, 4, 8. 9 is composite because it's 1 and 9 and 3 and 3. It has more than 2 factors. 10 is composite. 11, 12 is composite. 13, 14 is composite, etc. Okay. I'm going to have you two, 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 you 3. Okay, 3 of you. So what we're going to do, one of you is going to explain to the other what a prime number is. The other one's going to explain what a composite is. Okay, in your own words. You can read it off the paper if you're really not like, I don't know. I don't care. You're going to turn to one, turn to the other. You're going to explain composite to one person, prime to the other. I don't care who picks which. That's on you. Go. Multiples of a number. Now, I know multiples gets taught early, like really early. Yeah, super early. Multiples of a number are the number, and then the next number that it goes up by would be just adding that number on. So if it's a multiple of 3, what would be the first number? 3. And then the next number would be going up by that number, 6. Then the next 9, then 12. The hardest part of multiples I find with people is they get multiples and factors mixed up, first off. And second off, if they do multiples, they don't start with the first number being the number that they actually say. So if it's a multiple of 3, it starts with 3. Okay? So a multiple of 3 is 3. Then 6, because it goes up by 3, then 9, then 12, then etc. So if I explain this to a person, I would say a multiple is a number that starts with the number and then goes up by that number. So a multiple of 4, I would start with 4, and the next one would be 8, then 12, then 16, then 20, and etc., 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 right? So the thing with these ones, and you're going to see it when we come to the examples, is they have to give you like a group of numbers that it goes to. So it might be like the numbers less than 20. So then you stop at 19, right, or something like that. Factors. Factors are numbers that multiply together to give you that number. Multiply, I should say numbers, that multiply together to give you that number. So prime factors, a prime number has 2 factors. Composite number has more than 2 factors, right? So if I said factors of 12, you'd start off with 1, and then you could just say 12 next. I like doing them in order because it brings like calmness to my soul. So I would go like 1, then 2, 1 and 12. Some people do it like this when they're younger. 2 and 6, 3 and 4, And your teacher always used to say, they have to be in order. They don't. That's like, it's like brings, like, when we see 1, 12, 2, 6, 3, 4, it makes us like, have like, inside, but it's totally fine. There's nothing wrong with that, right? Listing the factors that way. If you list them in order, you'll see that this lesson that we're learning makes it easier. Divisible by 5. The number's divisible by 5. What does divisible mean? Divisible by 5. Anyone have any guesses? Kind of like multiple, yeah. It's divisible by 5 when you divide it by that number. If it's divisible, you don't get decimals. You don't get remainders. You know, like we used to do long division, you probably don't remember it, but you would get a remainder. If you got a remainder, it wasn't divisible by the number you were dividing into it. So divisible by 5 means you divide it. Divisible means when you divide, you get no remainders. You do not get remainders. So what's a number that's divisible by 5? 5. So 5 is divisible by 5. What else? 10. 15. So when they said multiples, technically it is the same, right? Then we're going to flip over. Okay, here's where we get more definitions. I promise you life is not like this in all of Math 30-2. It's not like definition life. This is heavy. This is probably the only lesson that's really definition filled. Okay? So don't go home and think, oh my gosh, we do definitions every day. No, it's today and then never again. All right? So here we have, in mathematics, a set can be defined as a collection of distinct objects. And whenever something is a set, just like when you listed your domain and range in set form, you would always go squiggly bracket, right? So whenever you want to list a set, you're going to do the squiggly brackets. Now, no one's marking you on your squiggly bracket. They're not going to be like, this is the ugliest squiggly bracket I've ever seen, 0.5 off. Okay, they're not. However, if you do this, and you say, that's my squiggly bracket, that is not your squiggly bracket. That is a square bracket, and it means something totally different. In domain and range, that actually means equal to. This means not equal to. So the squiggly bracket actually means the set of. It has to be squiggly. So if you think like, that's squiggly, that is not squiggly. Like if yours is like a forwards S, a backwards S, that's squiggly. So on the left-hand side, it's a forwards S and a backwards S. On the right-hand side, it's a backwards S and a forwards S, if it makes you draw a squiggly bracket. I just practiced them. Or it's a person with a really bad forehead, chin, and nose, or something. Whatever you want, it has to be squiggly. You understand? Square brackets are not wanted here. Okay? All right. So, an object in a set is referred to as an element. So if you list something in here, say we go like this. This is the set with an element that is 1. That it has one element in it. And the element is the number 1. All right? So this one here says the example, the number 5 is an element of the set of a number of that was some really bad reading. The number 5 is an element of the set of numbers on a die. So if I wanted to do that, I could go, okay, the element is 5. If it's a 6-sided die, what are all the elements on a 6-sided die? The number 1, the number 2, the number 3, the number 4, the number 5, the number 6, right? Those are all the elements on the 6-sided die. And here it's showing that example. So this is the way we could represent it. Or we could say the natural number's less than 7, because the natural numbers start at the number 1, and then less than 7 stops at 6. So they could list it that way. Or they could say x is less than 7, and x is an element of naturals. We often just show it this way. I just wanted to show you that there was other ways they could show it. They often just list the numbers. You just list them in a set. So here it says, the curly brackets together is read the set of. I'm not joking. It's a definition in a math textbook. If you put a front squiggly bracket and a back squiggly bracket, and you see those, that means the set of. That is the definition. Front squiggly bracket, back squiggly bracket. So in domain, you'd say the set of x values such that x is an element of the reals, close the squiggly bracket. You were taught that in every other year in math. Okay? The straight up and down line means such that, and E means a member of or is an element of. We're not doing domain right now, but I'm just going to prove to you that you've done this before. So you've said the set of X values such that, that's why you do straight line, X is an element of the real numbers, and then you close the squiggly bracket so that it reads the set of. Every single symbol that you do in math is actually a definition of a word. So the squiggly brackets mean the set of, straight lines mean such that X is an element of the reals. Like you can actually read that in a sentence. Okay? So here we have the number of elements in set A. On a diploma, they'll write it as the number of elements in set A. What we'll see in books is a little n of A. It's like this, little n of A. And that means the number of elements in A. So if I just say, what is set A? We're still talking about a six-sided dice here. Numbers 1, 2, 3, 4, 5, 6. Okay, for all these examples, we're doing a six-sided dice right now. If I wanted to list the number of elements, I would go 1, so set A equals 1, 2, 3, 4, 5, 6. But if I go n of A, or the number of elements in A, how many are there? 1, 2, 3, 4, 5, 6. So I list a 6. There are 6. So if I ask you for what is set A, I do the squiggly brackets and I list what the outcomes are. If I ask for how many outcomes there are, I would go, there are 6. I don't put the squiggly brackets because the squiggly brackets would mean the element is 6. I want to know how many there are. Why would they do that? Why would they ask for the number of elements in it? Where would that be helpful on a test? What if there was like 10 elements? Where could I ask that where it would be appropriate? Numeric response? Can you list 10 elements in a 4-box numeric response? No. Can you list the number 10? Yep. So they might just ask you for the number of elements so that you can put 1, 0 in the boxes. Okay? Now today I told you is a lot of notes because we're doing definitions first. Most often how we'll start the class, we'll start off with a little quiz, you work through it, then we'll go to a question, and then you're going to work on a few questions, and we do a question, work on a few questions. It's not going to be just like notes for 80 minutes. Okay? Today it's just heavy that way because we're doing definitions. All right. So note the number 2 belongs to set A, but the number 8 does not belong to the set A, so it can be written like this. 2 is an element of the set A. 8 is not an element of set A. And I told you this before, the order of listing the elements, or like I was talking about factors, does not matter. 1, 2 makes my heart sing, 2, 1 doesn't, but it's, you get full mark either way, because order doesn't matter. Okay? So we're going to look here. Consider the following 2 sets. I want you to list here what you think the numbers would be in this set and what you think the numbers would be in this set. The first set is whole numbers. Where do whole numbers start at? What number is the first whole number? 0. One with a whole. Less than or equal to 3. You list them. There should be 4 numbers. List them in there. 0, comma, and then list.
Rocking hot. It's like 25 in here. Perfect temperature to learn, I'm sure of it.
And then this one is even whole numbers less than 10. Even whole numbers less than 10. Try and list even whole numbers less than 10. So if you list it up there, it's totally fine because that's where I listed it. I'm going to list these down here. So P is the set of, what are the numbers in the set in P? Whole numbers, so I start at 0. And then my next one will be 1, and then 2, right? Less than or equal to 3. Does 3 get counted in this? Yes, because it is equal to. Boom. 3. Done. Just got full marks on that first set. That's how hard it is. Or not hard it is. Okay? So if you don't know your definitions, is this a really hard question? You don't know what a whole number is. Yep. Because you don't want to start at 0. Q are the even numbers, even whole numbers, less than 10. even whole numbers, and they consider 0 to be even on a diploma, they'd have to specify that. 0 is even. Often what they'll do is they'll go even natural numbers less than 10, completely kicking out the 0 being an issue, right, of whether it's even or odd or nothing, neutral, okay? So even whole numbers less than 10 would be 0, 2, 4, 6, 8. Is 10 included on this one? No, because it says less than 10. It doesn't say equal to, correct? It says less than 10. So I stop here. We agree? Okay, now we do n of p. What does that little n in front mean? Does anyone remember? Number of elements. So this just means the number of elements in P. So when it's an n, it's just like a number. It's like 7, 4, 3, 9, 2, 5. It's how many elements there are. So I go to P and I count the numbers. How many numbers are there in P? 4. How many elements are there in P? 4. That's it. So it's just asking for how many elements, how many different numbers there are in P, right? There's 1, 2, 3, 4. So it equals 4. It doesn't equal squiggly bracket 4. Squiggly bracket means the set of. It's an actual element in there. I don't want to know what the elements are. I want to know how many there are. How many are there? There's 4. So I put the number 4 because that's what I'm answering. Okay? N of Q means the number of elements in Q. How many elements are there in Q? There are 5. Does that make sense? So look down here. Here's an example. This one says, Betty is defining sets using non-negative. Non-negative means not negative. So like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Single-digit numbers. Single-digit means I need to stop at what number? 9. 10 I can't include because it has 2. So I have to stop at the 9, can't include the 10. Okay? Non-negative, single digits. So I'm going to list the first ones for you. Even numbers. My even numbers would start at 0. It just needs to be not negative. 0 is not negative. 0, 2, 4, 6, 8. I have to stop there because 10 is a double digit. Okay? I want you guys to try L and O and then see if someone beside you has the same answers. So, whole numbers less than 7. What does the whole number start with? 0. And then we have to go 1, 2, 3, 4, 5, 6. Can I list 7?
No.
Why don't I list 7?
Less.
It says less than 7. What would it have to say in order for me to include 7? Less than, at, or equal to, right? And then odd numbers less than 7. 1, 3, 5, and then I list 7. Do I list 7?
No.
No, why? Less than 7, not less than or equal to, right? Oh, I just wrote it now. I really like the number 7. It's nowhere else. Okay.